Hello. So in this presentation we will be talking about order of operations. The learning goal for this presentation is to understand how to solve a mixed operation problem following the correct order of operations. There are different levels of operations. Some have to be performed before the others. The very last one that we will be performing is addition and subtraction. So in this example here, we only have subtraction and addition. We don't have any other operation to worry about. So when that happens, when you have only addition and subtraction, you operate from left to right. So we will be doing 6 minus 3 first, which is 3, and then we will add 2, which will be 5. Now, the next level is multiplication and division. So if we see multiplication and division, we do that before we do addition and subtraction. Here we have an example where we only have division and multiplication. So same as before, when we only have operations in one level, we move from left to right. So we do 16 divided by 8, which would be 2, and then we multiply 2 times 2, which would be 4. In this other example, we have a mix of levels. We have subtraction, which is level 4, and division, which is level 3. So again, we do the level 3 first before we do the level 4. So we do the division first. 8 divided by 2 will be 4. And now we can do the subtraction. 7 minus 4 will be 3. In this other example, we have a mix of addition and multiplication. Again, multiplication is performed first. So we do 5 times negative 2 first, which is negative 10. And 3 plus negative 10 is the same as 3 minus 10, which would be negative 7. A higher level than multiplication and division is exponents and roots. That's category 2. So here we have an example where we have multiplication 3 times and then a square root of 12 plus 4. So we have several operations here, right? We have multiplication, a square root, and addition. So according to the rule, we should start trying to do the root first before we do multiplication or before we do addition. However, in this example here, we cannot do that. We cannot square root 12 plus 4. Before doing that, we have to actually add 12 plus 4. So every time you have something inside a radical symbol, right, this is called the radicand, you have to have only one number in the radicand. You cannot have a combination of numbers, okay? So you have to generate only one number before you can proceed to do the square root. So in this case, we have to do this addition before the square root. Again, the reason is because 12 plus 4 have to be added to generate only one number. We need only one number under the radicand, okay? So 12 plus 4 will be 16. Now that we have only one number, now we are able to square root that number. Before we couldn't. Now we follow the order of operations according to this. Square root of 16 will be performed before the multiplication because square roots come before multiplication. Square root of 16 is 4, and 3 times 4 equals 12. Now let's see this problem here. Here we have an addition and an exponentiation. So according to this rule, the exponents are performed first. 5 to the power of 2 is 25, and 25 plus 3 is 28. And the highest level are the parentheses, braces, or brackets. All these are grouping symbols, right? They group some operation together. So here we have parentheses. So we have to perform that before. Whatever is inside the parentheses have to be performed before everything else. So we have to do the 3 minus 4 first, which would be negative 1. And now we multiply 5 times negative 1, which would be negative 5. Now that we have seen several examples, simple examples, we will have more complex problems to solve. So let's start working here with this problem. So here we have 7 minus 24 divided by 8 times 4 plus 6. Again, we have to see which of these operations has the highest hierarchy. So there is only addition, subtraction, multiplication, and division. So remember that the multiplication and the division are performed first before the addition and the subtraction. So we have to do these guys first. And if we have several examples of multiplication and division, we move from left to right, right? So right here I start moving from left to right. Where we have subtraction, we ignore that. Here we have division. So that's what we do first, the division. Okay? So 24 divided by 8, right? So it would be 3, right? 24 divided by 8, right? It would be 3. Now remember, we can take the symbol here if we want to, but 7 minus this, or we can separate it better to avoid confusion. So this would be 7 minus 24 divided by 8, 3 times 4 plus 6. Now 3 times 4 is 12. That will be the next one, because after that division, what is to the right is the multiplication. 3 times 4 is 12. So this will be 7 minus 12 plus 6. Now that we have only addition and subtraction, we can perform all of these guys from left to right. 7 minus 12 will be negative 5 plus 6. The answer would be 1. Okay? Okay, so now we go into the next problem. Here in this problem we have exponents, division, parentheses. So parentheses have to be performed first. So we have to work on these parentheses and on these parentheses independently first. Now inside the parentheses we have to follow the order of operations as well. So exponents come before multiplication and division. So first is 5 to the power of 2, which is 25 divided by 15. Right? Now that we have performed that, we can see what we have. We have multiplication and division. So they are at the same level, so we move left to right. 3 times 25 is 75. And 75 divided by 15, it will be 5, I believe. 5 times 5, 20, 25, 5 and 2, 5 times 1, 5, 6, 7. Yeah, so this will be 5. Now here we independently work on this other problem, or part of the problem. So here it will be 5 minus 2 to the power of 2 is 4, because 2 times 2 is 4. And 5 minus 4 is 1. So this will be minus 1. 1. Basically it will be like this, minus 1. 5 minus 1 equals 4. So that will be the answer for this particular problem. So let's go into another problem. Here we have a numerator and a denominator, a fraction basically. In the numerator we have a mixed group of operations, and in the denominator we have addition. So we have to treat the numerator and the denominator like independent blocks, okay? Because here we cannot divide this whole thing by 2 or by 6. No, we have to add that 2 and the 6. So we can work independently in the numerator and denominator. The denominator will be 8, okay? And again, the question is, why am I doing addition first before exponents or roots or anything? Is because the numerator and the denominator have to be treated independently from each other, okay? So I do 8 here, and now I'm going to focus on the numerator. You can work also on the numerator first, but then when you work in the denominator, you have to add them. That has to be a step you have to take. Now, here we have an exponent inside a root. Remember, whenever you have several operations inside a root, you have to generate only one number inside a root. Otherwise, you cannot square root these numbers here. So you have to generate one number. So here I'm going to do this. I'm going to say this is 20 minus 2 to the power of 2 is 4. And then we multiply times 6, all that. Okay, now 20 minus 4 is 16. So let's do, it will be square root of 16 times 6 divided by 8. Square root of 16 is performed first before the multiplication. Square root of 16 is 4 times 6 over 8. 4 times 6 will be 24 divided by 8, and that will be 24 divided by 8 will be 3. That will be the answer to this problem. So again, I want to emphasize that we follow the rules first, parentheses, brackets, braces, all those things, grouping symbols. Then we do exponents, right? Or square roots or cube roots, any roots. Then we do multiplication and division, and at the end we do addition and subtraction. However, whenever we see something inside a root, we have to do that first, whatever is inside a root, to get one number. Otherwise we cannot square root or cube root whatever is inside, like in these examples. Inside a root we follow the rule. We see a subtraction and exponent here, so we do the exponent first, then do the subtraction. Anyway, we'll see one last problem here. This problem is very simple too. Again, 2 is raised to a power, but that power has to be one number. It cannot be 6 minus 3. So even though the exponents have to be done first, because this exponent is not clear what to be a one number, is combination of operations, we have to do that first. So this would be 2, 6 minus 3 is 3, and 2 to the power of 3 is 8. Again, we're doing subtraction before doing the exponent, because that exponent is a combination of numbers with operations. So we cannot do exponents before we know what number this is going to be at the end. Now we know it's 3, now we can proceed. Okay, it's the same criteria as the roots. Well, thank you very much.